Vector, summation, and integral calculus. Vector summation and integral calculus, the war we have waged now. Vector summation and integral calculus, how I can solve a kind of problem. We are talking about a bank loan issue. Okay, people can deposit money in the bank. People can take loan from the bank. There can be many scenarios. Okay, we were talking about there is a fixed deposit in the bank, and fixed deposit a person is depositing y0 amount at the beginning. Y0, y bottom right as a subscript 0 means y amount some person is depositing in the bank on the 0th year. Time is in year now. 0th year, a person is depositing y amount, that is called y0. On the 0th year, at the beginning, person is depositing y0 amount. If person is depositing y0 amount, then how much that amount will be after t number of years, where t is small t. After t number of years, after t number of years, what is the amount that person can expect in his account? What is the amount that person can expect in his fixed deposit account after t number of years? Okay, in that fashion, if this is typical case of compound interest, compounding will happen every year. Every year, principal amount plus interest. Okay, person is depositing y0 amount at this is timeline. This is 1 year. This is second year. At the end of 1 year, y0 amount will become how much? It will be y0 plus y0 into c. C is the interest rate per year. Net it will become y0 bracket 1 plus c. At the end of 2 years, y0 in bracket 1 plus c into, sorry, y0 in bracket 1 plus c plus y0 in bracket 1 plus c bracket close into c. It will become y0 1 plus c whole square. Okay, y0 and in bracket 1 plus c whole square. At the end of t years, it will become y0 in bracket 1 plus c bracket close to the power t, where t is in years. Then after that many years, the amount will, after t years, the amount will come to that stage. Consider 1 plus c equal to a. Then it is y0 a to the power t. Makes sense? Now, can I expect that after t years, the money in the account will be zero? What do you mean? The money in the account will be zero after t years. This means that someone else is a proud guy, and every end of the year he is withdrawing S amount from the account. There is a proud guy. He came to know that I have deposited y0 amount in the account, and it is going to become a to the power t, y0 into a to the power t after t year. That mischievous person is withdrawing S amount every year. I don't know. And after T year, when I'm going to the bank to see how much my money has come as per the calculation, it would be y0 into a to the power t. But it is exactly zero after T years. That moment, after T years, I'm receiving a notification that your amount has become zero. So how come? Someone is withdrawing S amount every year, S amount every year. Means whatever interest I am getting every year, okay, someone, then how much someone should withdraw S amount every year, that after T year it will become zero. This is one scenario. Another scenario is a friend person in the fixed deposit account, he is depositing S amount every year without my knowledge. My knowledge is I have deposited Y0 amount in the bank, fixed deposit, compound interest, and after T year it should become Y0 into A to the power T. But some good wisher, well wisher, He is depositing S number of amount every year in my account. So what will be the amount in the bank? These are the questions. What can be another question? I have taken loan from a bank Y0 and I'm going to the bank and I have taken a loan. If I take a loan, bank opens a new account for me Y0. Y0 loan that can be $100, $1,000, 1,000 rupees. I have taken loan from the bank. If I have taken loan from the bank, then what is the amount that I have to repay every year? Every year, at the end of first year, I have to repay some amount. If I repay every year, if I repay every year, then after T year, that is small t, after T year, it will become zero. Loan will become zero. All are same question. All are similar question. Now, what is similar here is for the simplest, let's assume that I have deposited Y0. First case is I have deposited Y0 and after T year it will become Y0 into A to the power T, where A is 1 plus C, where C is the interest rate per year. Second is that I have deposited amount in my bank and then someone is withdrawing S amount every year. Okay, after T year, small t year, it is becoming zero. Or I have taken loan from bank Y0 amount. How much I should deposit S amount every year that after T year it will be repaid back. Because every year if I delay, then Y0 amount, the interest on that is happening. These are similar questions. Okay, I am not here to go detail in it. But the question is if I have deposited Y0 amount at the end of T year, it is becoming A to the power T. A is 1 plus C. Now, if I am going to another bank, he is saying we are also giving C percent of interest every year. But compounding will happen every month, not every year. What do you mean by every month? Every month, if C is the interest rate per year, then we do the compounding every month. Means C by 12. That is the interest we will get every month. C by 12. Then it will become 1 plus C by 12 is the interest rate. 1 plus C by 12%. That is 1 plus C by 12 into 1 by 100. 1 plus C by 12 into 1 by 100. C by 12%. Okay, then what will be the amount at the end of 1 year? Actually, it will go for 12 slabs. Consider this in 1 month, 2 month, 3 month, 4 month. It will go for 12 slabs. Each slab he is getting interest of C by 12, where C is interested at the end of 1 year. After 12 slab, how much money he can expect? And that is Y0 into in bracket 1 plus C by 12%, that is 1 by C by 12, 1 plus C by 12 into 1 by 100 bracket close to the power 12. Okay, that much money he can expect after end of 1 year, and that will be more than C. The interest, net interest at the end of 1 year will be more than C. Okay, this is after 1 month, 1 year. How much money someone would expect after T years? Then Y0 in bracket 1 plus C by 12 into 1 by 100 bracket close. On top of it, it is 12. That is for 1 year. 12 into T. That is for T number of years. What about if I divide my C interest into N part? Now I have divided C interest into 12 parts. Considering things will happen every year. Considering things will happen every year. If I divide into 12 n part, now I am dividing into 12 part. Then it will be y0 in bracket 1 plus c by n bracket close to the power n into t. Total it is y0 in bracket 1 plus c by n bracket close to the power n into t. Okay. Now, if I say n tends to infinity, then if n tends to infinity, then what will happen? If n tends to infinity, then 1 plus c by n to the power n is e to the power c. We have proved it already. Consider y equal to 1 plus c by n whole to the power n. Log of y equal to n log of 1 plus c by n. If that is the case, then log of 1 plus c by n, where n tends to infinity, it will be equal to c by n into n, c. Log y equal to c, y equal to e to the power c. More or less, the computation comes in y equal to y0 e to the power ct. This is what we have seen. This is covered. Y0 equal to y means the amount in the current account after any time t. Y as a function over t, small t, equal to y0, amount that was deposited at time equal to 0, into e to the power ct. Makes sense? This is called compound, continuous compound interest, means compute continuous compound interesting formula, interest formula. Means compounding is happening every moment, not at the end of 1 year, every moment, not at the end of 1 month, 1 day, 1 day, 1 second, every moment. That's why n tends to infinity. Okay, then it is y equal to y0, or y as a function of t, yt equal to y0 e to the power ct. Okay, now if a well wisher is depositing the s amount in this fixed deposit account every year, for the first s, the bank will give interest for t minus 1 year. Because if this is the first year, then Y0 was deposited at this time and S is deposited at this time. So S will get interest for 1 year less. Okay, then person is depositing S amount at the end of second year also. Here S amount is deposited. He keep on doing like that. If that is the case, then there are many S amounts are coming in the account. How many S? T number of S. If I'm trying to calculate how much money is there in the account after T years, then T S amount he has deposited in the account. Then we have seen, then every s will become s into e to the power ct. For first s, it is s into e to the power c in bracket t minus 1, 1 year less, like that. What is the net y I can estimate after t number of years? Yt equal to y0 into e to the power c of e to the power ct plus, that is for the y0, plus s e to the power ct minus 1 plus s e to the power ct minus 2 plus s e to the power t minus 3 plus s e to the power t minus 0 at the sorry, t minus t e to the power c in bracket t minus t at the end of t years. More or less, it will become yt equal to y0 e to the power ct plus s, and in bracket e to the power c in bracket t minus 1 plus e to the power c t minus 2 plus e to the power c t minus 3 plus e to the power c t minus t, that is e to the power 0, 1. Can I find summation of this? That is the question. Can I find? Then I have to, what you want to know? E to the power c minus e to the power e exponential e to the power c, and in bracket t minus 1 plus e to the power c bracket t minus 2. Compute it plus e to the power 0. Consider this summation I divide into n different part. Each part, rather than saying e to the power c t minus 1, I say e to the power c t minus x. This is called sampling. This is typically called sampling. What do you want? What do you want? What do you mean by sampling? Sampling means I am saying that there is a algebraic equation. What is algebraic equation? This is x-axis. This is origin, and there is an algebraic equation like this. There is a algebraic equation like this, like this. Now, like this means, what is the function of this algebraic equation? Function of this curve is e to the power c. C is the interest per year in bracket t minus x. This is what? Then this proves that this is x-axis. Yeah, this is x-axis. This is x-axis. This is x-axis, and there is a curve. there is a curve and it curve and equation is e to the power c in bracket t minus x. That is the equation of the curve. Okay, thank you very much. Then what you're trying to do? So it is something like I have sampled this curve at now this is the curve equation of this curve is e to the power c in bracket t minus x. I have sampled this curve at many locations. What is the location? One is at x equal to 1, one is at x equal to 2, one is at x equal to 3, like that. Okay, what do you mean? Anyone can think now. First sampling will give e to the power c t minus 1 because x is 1. One next will give e to the power c t minus 2 because x is 2. Like that at the end e to the power c t minus t means you're trying to calculate addition of all the sampling. Yeah, sampling means height. If this is the curve, if I sample this curve at x equal to 1, it will go and cut it here. This is the height. This height is at x equal to 1, this height is e to the power c in bracket t minus 1, t minus 2, t minus 3 like this. Can I add all these heights? Okay, to add all these heights, then the actual problem is e to the power c t minus 1 plus e to the power c t minus 2. All together I divided into n different part or t different part because these are in number of t different part. Each part rather than saying e to the power c t minus 1, e to the power c t minus 2, I am saying it is e to the power c t minus x. All are e to the power c t minus x. There are two ways to solve it. First of all, I have divided into t different parts and then I'll solve part by part. That is the concept here. How I can divide my problem into n different parts and solve part by part and then sum it. Each part is e to the power c in bracket t minus x. Each part. One way is if anyone has a repeated summation, this will fall under repeated summation. Repeated summation means if I have 5 plus 5 plus 5 three times, 5 plus 5 plus 5 three times, I can show it in diagram as this is x-axis and when x is 1, I have a vertical called 5. Vertical called 5, vertical called 5. What do you mean? Consider there is a parallel line like this. This is x-axis. There is a parallel line like this and height of this line is 5. Now, when x equal to 1, I do a sampling. When x equal to 2, I do a sampling. When x equal to 3, I do a sampling. Then I have three verticals. What is the length of total length of this vertical? 5 plus 5 plus 5. That is 5 into 3 or 5 into x where x is 3 or 5 into dx. Now x became dx, then one limit will appear automatically where x is 0 to 3. X is 0 to 3, 5 dx that is 5x, x is 0 to 3 that is 5 into 3, same as 5 3 times. Okay, now we have e to the power c in bracket t minus x, that is how many times? X times, where x is t right now, t times, small t times. E to the power c in bracket t minus x into dx, where dx will go 0 to t. Someone can try e to the power c t minus x dx. If I do integration, then it will become minus 1 by c and then e to the power c t minus x, where x will go 0 to t. That will become 1 minus e to the power ct. 0 to t, if I place t there, t minus t is 0, that is 1. If I place 0, then t minus 0, that is t. That will become e to the power c e to the power ct, 1 minus e to the power ct, minus is outside, 1 by c in bracket e to the power ct minus 1. Okay, if I place in the big equation that is yt equal to y0 e to the power ct plus s and in bracket e to the power ct minus 1 plus e to the power ct minus 2 e to the power plus e to the power ct minus 3 plus e to the power 0 that is 1, then full the summation will be replaced by 1 by c in bracket e to the power ct come down minus 1. Total it will become yt equal to y0 e to the power ct plus s by c and in bracket e to the power ct minus 1. This is what the result that is available in the book. Okay, can there be another philosophy in calculating it? One, where we have divided my problem into n different parts, and each part is e to the power c in bracket t minus x. Means if I have a curve like this where I have done sampling, this is a curve e to the power c, and in bracket t minus x, I have done the sampling of this curve at x equal to 1, 2, 3, 4, 5, 6, 7, 8 up to t. Means I have so many verticals are there, and all verticals are of same height e to the power c in bracket t minus x. Okay, if I make x constant, if x is varying, then vertical will vary with the x. If x is 1, then height is e to the power c t minus 1. When x is 2, this is x-axis. When x is 1, when x is 1, then height is e to the power c t minus 1. When x is 2, then height is e to the power c t minus 2. When x is 3, then height is e to the power c t minus 3. When x is t, then height is e to the power c t minus t, e to the power 0, 1. That will be the height. It will grow like this. So at the beginning, the next net computation is more. Okay, what is this computation? One formula that we are proposing, what we talked about previous formula, that also we only brought, that is not available in the book. What we are going to talk now, this is also not available in any of the book. Okay, this concept we have named it as approx as continuous approximation in integral calculus. Continuous approximation in integral calculus. Similar to that, means someone would do our regular approximation. Approximation. What do you mean by approximation? What you have, I have t number of verticals that I need to add it. But if I connect the top of all the vertical, it will give a function that is called fx. But this is not a continuous function sampled at x 1, 2, 3, 4, and I have vertical that I need to add. How I can add? Okay, if I say this function name is fx, then fx dx, x is from 0 to t, will give the solution. That is the question. Okay, actually we tried that and we got the solution. This is what is printed in the book. This may not be perfect, but this is how it is. How it is not perfect? When t equal to 1, then how much money will be in the account? Y0 a to c e to the power ct. T is 1. Y0 e to the power c. That will be the amount in the bank because of Y0 that got interested for 1 year. What about S? S did not get any interest. So it will be plus S. But with this calculation, it is S by C, and in bracket e to the power Ct minus 1. T is 1. E to the power Ct. E to the power C. C is, if I say C is 8%, then e to the power 0.0. E to the power 0.08. How much it will be? E to the power 0.08. That is near to 0 only. E to the power 0 is 1. It will be little high. Minus 1. Whatever it comes multiplied by S by C. Okay, S by C means e to the power C. E to the power at the end of 1 year. E to the power C minus 1 divided by C. We expect that this will be near to 1 because we want S. I believe it is alright. At the end of 1 year, how much money I have in the account? Y0 will get interest for full 1 year. That is Y0 into e to the power Ct plus S amount someone is depositing at the end plus S. But as per our formula, it is e to the power Ct plus S by C in bracket e to the power Ct minus 1. If t is 1, then first is y0 e to the power c. That much money will come in the account because of y0. What because of s? There is no interest there because s is deposited at the end of 1 year. But here it is e to the power c minus 1 by c into s. I expect that e to the power c minus 1 by c should be should be equal to c only, means e to the power c, e to the power c should be equal to 1 plus c. Then minus 1 will be c, c by c will be 1. Okay, this is what the expectation is, but it will not be, it may not be 1, some fraction will be there. Means this is not a complete solution what is mentioned in the book. This is what we are here. Okay, this is not the complete solution. Understandable, right? This is what is placed in all the mighty books in calculus. This is what the solution is. And I would say this is not perfect. Unnecessarily, you are giving interest to your client unnecessarily. Something. What interest you are giving to the client at the end of 1 year is e to the power c minus 1 by c, whatever it comes. That means extra money you are multiplied by s. Okay, multiplied by s. If this term is more than 1, then s into this term, s into e to the power c minus 1 by c minus s. That is the extra amount you are depositing in the customer's account. This is what we are saying. What will be perfect solution for this? For perfect solution for this, let's go by the, for perfect solution for this, let's go by the initial concept. What is your initial concept? The initial concept is, consider I have a length is going from 0 to 1, and there is a parallel line like this, and whose height is 5. Makes sense? Height is 5, this height is 5, and there is a parallel line this. I do n number of sampling of this line. If this is the top line, I am doing n number of sampling between 0 and 1, n number of sampling. Consider I am doing 10 sampling. If I do 10 sampling, then I have a height as 10 bar, 10 verticals I am getting because I did 10 sampling. One vertical is at x equal to 1 by 10. One is at x equal to 2 by 10. At the end, I have last one at x equal to 10 by 10. What is this addition? The someone will say it is easy, right? 5 plus 5 10 times. 5 into 10, that will be 50. Okay, can we compute it through integral calculus? Okay, to compute it integral calculus, consider this is a line equation fx. If I say fx dx, where x is from 0 to 10, then it will give underneath area. Is this area is same as I sum n times, 10 times? Certainly not. Certainly not. Let's try. If I say my fx is 5, 5 dx, 5 dx, that will become 5x. X is 0 to 1, that will become 5. Whereas if I add 5 10 times, it is 50. And here it is. This is what I made a chop of 10 times. I can make chop of 10,000 times also. Then it will be 5 into 10,000. 50,000 will be the addition. Whereas if I make chop of how many you want, the area will be same underneath, that is 5. 0 to 1. Then how I can calculate this summation through integral calculus? Okay, another solution is I have to think about another function. This fx will not work because fx dx 0 to 1 will give constant area, whereas I am free to chop this line between 0 and 1 n number of times, where n can be anything. I am free to do it. If I chop only once, then it is 5. This is what we are getting through integral calculus. Means I have to think about another function called gx. This is fx, then another function called gx. And gx dx between x equal to 0 to 1 will give the area. And that area will be same as summation of all fx. Makes sense? Okay. Now consider that I am dividing my problem. This is very big thing. We have also talked, I believe, 1 month, 2 months back also. We are pursuing in more detail. Now consider that this is fx and I am chopping it into 10 different times. Now each time I have a vertical, then I have next vertical, next vertical. What is the gap between these two verticals? Gap between these two vertical is 1 by 10. Okay, then what is the area of this? Okay, what I'm trying to say is, consider that this is, how I can say, this is fx. what I am getting through integration, what I am getting through summation is pretty clear. Okay, this line is getting added 10 times. That's it. How much the gap is doesn't matter. I have sampled it 10 times, then everywhere I have a line length of 10 times. How much will be the addition? Addition will be 5 into 10, 50. If I consider the same horizontal line as a function fx, and I'm trying to calculate integration, then what I am getting? Consider this is x-axis, and this is fx that is equal to 5, and then I am doing fx dx from x equal to 0 to 1. Then I am trying to calculate this area. If I talk about this area, then I am dividing this x. Consider I divide this x into 10 different parts. Then let's talk about at any from this is origin, and this is x-axis going to 1. Take any point called x. If I take any point x, then at that point I have a vertical that is fx. Makes sense? And then what is the if I chop it 10 times? If I'm trying to understand what is fx dx. Okay, then where is the next chop? The next chop is at a distance of 1 by 10, because 10 times I have chopped. If this is x, then next is x plus 1 by 10. If this is x, then another is x plus 1 by 10. Okay, what is area of this strip? That is fx dx, where x is x to x plus 1 by 10. If I add all this substrip from here to here, if I add all this substrip, it will become fx dx. X is 0 to 1. Makes sense? If I have, if there is a, if this is fx, fx, and underneath area is this much. Okay, if I cut this area, if this is the area, I cut this area into n different parts. I take a point on x-axis as x, and another point is x plus 1 by 10. Then this is the sub area. If I add all 10 sub area, it will become full fx dx 0 to 1. I can chop it into 100 time also, 1000 time also. Then each subsection area will become smaller, smaller, smaller. Okay, at the end, fx dx 0 to 10 will be same, should be same. More times we chop, it will be near to the actual exact result. Okay, what we are trying to do now? One side I have repeated summation of the vertical that I chopped 10 times, that is 5 into 10. Other side, I have some function called gx, this was fx. Consider I invent some function called gx. If I invent function called gx, another function, then gx dx x to 0 to 1, that area should be same as if I do summation I equal to 1 to 10 f fx 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 10 times if I sum. If fx is 5, then summation I equal to 1 to 10 5 5 up. Okay, I want to earn 1 to 10 5, just 5 means 5 will be added 10 times. Okay, this 10 time addition should be same as gx dx area. What do you mean? What I mean is that if I have x-axis and there is a function called fx that is 5, if I take x equal to x, along this I take x equal to x, then I have a vertical called 5. If I talk about gx dx, then at x, if I take the gx, then I will have a vertical called gx. If I have a vertical called gx, if I see that all the verticals in fx, I divided 0 to 1 10 times, then this is x equal to 1, I have a 5, x equal to 2, I'm sorry, x equal to 1 by 10, I have 5 vertical, x equal to 2 by 10, I have 5 vertical, x equal to x, I have 5 vertical, x equal to x plus 1 by 10, I have 5 vertical. Now let's take these 2 points. At x equal to x, I have a vertical that is 5 for the repeated addition. Then at x equal to x plus 1 by 10, I have a vertical of 5 again. Makes sense? Now, between these two, there is no vertical. Means this vertical is covering this area, though it is not coming into computation. If I talk about integral calculus, so discrete addition is addition of all the vertical, irrespective of this length. This length does not matter. Matter is how many verticals are there and what is the length of one vertical. But if I talk about integral calculus, then vertical matters at any time how many sampling I have done. If I have done 10 sampling, then at x vertical matter, and then between x and another point, that length matters, because I am talking about area substrip in integral calculus. Where the repeated summation, I am talking only about vertical. Means if I have at x whatever is the vertical, if this vertical is exactly length is exactly same as whatever compute the sub area through integral calculus, then I have repeated summation of the sub area. That is what I am getting through gx dx. Whereas through vertical, I have repeated summation of vertical. That is, I am getting through fx. Summation I equal to 1 to 10 fx. All the vertical I am adding. Same thing I am getting through gx dx summation x limit x to 0 to 1. But their repeated addition is happening for the sub area in integral calculus. So at any x, what is the fx? That fx should be same as for any x, x to next section what I made. Okay, I cut it into 10 parts. So x to x plus 1 by 10, what is the area? This area should be same as the vertical. If both are same, then repeated summation of the area will become same as repeated addition of the vertical. If both are same, then we can find the solution. Okay, let's try now. 5, some repeated summation of 5 at x equal to x, what is the vertical? That is 5. Okay, that is 5. What we have said, fx repeated summation of fx should be equal to integration of gx dx, where I have to find gx. Okay, at the beginning, people can take anything like fx equal to gx dx, then gx equal to dfx by dx. There we can start it, because it is repeated approximation. This is the better word. Repeated approximation. Fx equal to gx dx, dx equal to dfx by dx. That is 0. 5 differentiation is 0. So we will start with integration 0 dx, that will come as 0. If it is 0, the area of the one section is 0, but area of that height is 5. Means here it is 5, here it is 0. Means I have to take 5 now. So now we will start with the 5 dx. Next step is 5 dx. Approximation we are doing. So integration of 5 dx from where to where? From x to x plus 1 by 10. I have done 10 chopping. From x to x plus 1 by 10, gx dx should be exactly as fx at x equal to x. At x equal to anything, fx is 5. So 5 equal to gx dx, x to x plus 1 by 10. Gx I have taken arbitrarily 5. First I had taken 0. Then it did not work. Then I took 5. 5 dx is 5x. 5x limit is x to x plus 1 by 5. 1 plus x plus 1 by 10. It will become, now x will cut down each other. It will become 1 by 10. Expectation is 5. I am getting 1 by 10. This is next step. Means I have to multiply this, whatever we have done, 5 dx by 50 now. Then only it will become 5, right? 1 by 10 into 50 will be 10. 1 by 10 into 50 will be 5. This is what I want. Now I'll multiply by 50 now. By 50. Okay, earlier I took 50. Now I have to take 50 into 50 and let's try. Now it is 250 into 50. Okay, so it is 250 dx. X is from x to x plus 1 by 10. Let's try. 250 x, where x is x plus 1 by 10 minus x, 1 by 10. 250 by 10, it is 25. Hope, we are making very wrong things, something like that. We'll try again. We tried with the 5 dx, 5x. X is x plus 1 by 10 minus x, 1 by 10. It came as 5 by 10, 1 by 2. It came as 1 by 2. But expectation is 5. I am getting 1 by 2. To get 5 from 1 by 2, I have to multiply it by 10, not by 50. 10. Now earlier we had 5, I am multiplied by 10. Now it is 50. 50 dx, x from where limit is x to x plus 1 by 10. It will become 50. 50 into 1 by 10. X plus x will go. 50 into 1 by 10, that will be 5 1. We have got our integral calculus. Earlier we have fx equal to 5. Now I have a gx that is 50, much above it, 50. If I integrate a 50 between 0 to x, then I'll get a result same as 5. 5 10 times. 5 is chopped 10 times. 5 into 10 is same as 50 dx 0 to 1. Makes sense? Okay, this is now repeated approximation. Can someone try? Now this is workable because we have taken a flat line. What about if I take a line that is x? Consider there is a line called x. X means when x is 0, height is 0. When x is 1, height is 1. Now I chop it into 10 times. 10 times. When x is 1 by 10, height is 1 by 10. When x is 1, 2 by 10, height is 2 by 10. Now add all those. 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 up to 10 by 10. Add it. We will try it again. Fx equal to, then what is the formula? Formula is x by 10. Formula is x. Formula is x. I am chopping at x equal to 1 by 10, 2 by 10, 3 by 10, 10 by 10. Formula is x only. Formula is x, fx equal to x. Then fx equal to, at x equal to x, the fx is x. Next one. Then here gx will be dfx by dx 1. We will try with the 1. 1 dx will be x. X will go from 1 to x to x plus 1 by 10. This is our proof. In that fashion, it will become now, I'm sorry, x, oh, it is x and fx dx. Dx will be 1. 1, that's what we tried. Fx equal to x equal to gx dx. Dx will be dfx by dx. Then it will become 1. 1 dx, that will be x. More or less, it will become 1 by 10. Here it is x and we are getting 1 by 10. Okay, means I have to multiply it with 10 into x. Then it will become x. Let's start again. Again, now if I multiply 1 by 10 into 10 into x, then we have to start with the x1. So we'll start with the x. X dx, x square by 2. If that is the case, x square by 2, then how much it will come from x to x plus 1 by 10. X square will be x square plus 2x into 1 by 10. That will be x by 5 plus 1 by 10 whole square, 1 by 100 minus x square. Okay, minus 1 by 2, leave 1 by 2 outside. 1 by 2, it is integration in x square by 2, leave 1 by 2 outside, x square. X square will go away, and 1 by 100 plus 2 by 5, 2 by 10, that will be 1 by 5x will remain. 1 by 100 plus 1 by 2 is outside. Okay, if I discard it also, then it will become 1 by 100 plus 2 by 5 into x. But this side it is x and here it is. So whatever we have done, I'll subtract with equal term. I had taken gx as x. I will take gx as x minus 1 by 100. Okay, and then multiplied by something so that it will become like that only. Means, or I can say x into 5 by 2 into 5 by 2, 5 by 2 minus 1 by 100, because that is extra we are getting. We will try it again. Keep trying till gx dx from x to x plus 1 by 10 will exactly become x. If gx is derived, then your answer is there. Then after that you can do dx 0 to 1, and that will give same as what we are getting here. Someone can try. We'll proceed in this. Okay, this is for x we did what we want. Then we will do for e to the power c t minus x. We started with 5, then we came to x. We will do for another few, 1 or 2, and then we will jump to our solution. E to the power c t minus x. the x that I sample at x equal to 1, 2, 3, 4 up to t. That function, how I can bring in another function gx, so that gx dx x to x, x is from x to x plus 1, because we are sampling at 1, 2, 3, 4. X is x to x plus 1 dx dx will be exactly same as e to the power c t minus x. If I am able to find gx in that fashion, we are done. This is the most perfect solution, better than whatever available in the world now. Okay, if any bank employee is watching it, then this is something that will give more profit to the bank, because unnecessarily they are paying to the client. Anyway, we will talk about it, and these are whatever we talk today, these are not available in any of the book. Please don't mind supporting us. +91 in the India country code 9483160661 is the telephone number. +91 India country code 9483160661.